All right, guys, let's look at I don't know, part 8, part 7. I don't know which part this is, but this is topic 6, excuse me, finding midpoints and endpoints as segments. And so this section is kind of in two parts. The last part I think is like probably the hardest of the two, but like this is going to comprise about 25% of your test, and so like this is actually a pretty major section here. Let's just jump into it. We're asked to find the midpoint, and so remember the midpoint is literally the point in between the two ends. And there's lots of ways we can do it, but like in the end, it's either going to be counting or calculating. All right, so let's just get into number one. For me personally, and this is just my kind of style, I like to work from a picture, and so I'm going to draw in the A value at 0, 0. And then I'm going to just kind of draw a segment to the B value, and I'm going to call it negative 8, 6. I don't think this drawing is accurate to what it actually would look like. I'm not really concerned about how it fit on a grid. I just want a picture in my head, and so I know that I'm going for the exact middle point. I'm going to just call it M. Okay? And so two choices, I can kind of count it out, but I don't have a grid, and that might be a little tough. So I can just go right for the formula. Now, this might differ slightly depending on whose class you're in, because we all have our own kind of personal style we put on it. But for me in my class, I define the x value of the midpoint and the y value of the midpoint separately. If I want the x value, I'm going to take the first x value of the endpoint, add it to the second x value of the other endpoint, then divided by 2, essentially taking the average. And then for the y's, which is completely separate, I'll do the same thing. So y1 plus y2 all over 2. Okay, for what it's worth, and I don't remember if I ever actually wrote this down, but this is the midpoint formula. There we go. Okay, so just like distance formula, this will work basically in any example, as long as we can feed these pieces in properly. But the nice part about this one is that it is completely separate. Oh, not you. And so I can take the x value, the midpoint, and calculate it completely separately from the y component. Okay, so dealing with the the x side first. Okay, that's weird. So we're just looking at the two x values, 0 and negative 8. So we have 0 plus a negative 8. Remember, two negatives make a positive, but if you have one of each, it actually just becomes a negative, and we'll divide that by 2. Okay, there we go. So 0 minus 8 would be negative 8. Divide that by 2, you get negative 4. And so the x value of that midpoint is going to be negative 4. Completely separately with the y's, we can take the two y values. Okay, so 0 and 6. Okay, so we have 0, add 6 to it, then divide by 2. That's the same thing as 6 over 2, which means the y value of the midpoint is just equal to 3 because 6 divided by 2 is 3. So using the midpoint formula, what we know is that the midpoint, the point exactly in the middle, should be negative 4, 3. Okay, now in terms of checking our work, this should make some sense, and I'll try to kind of explain why. If we start at 0 and then we travel to the midpoint, we're going from 0 to negative 4. That's dropping 4 values. Well, if I start at the midpoint and then go to the other endpoint, I should go the same amount. I should drop another 4 values, and it totally does that. 0 to negative 4, down 4. Negative 4 to negative 8, also down 4. 0 to 3 for the y values is up 3. 3 to 6, up another 3. And so we can kind of confirm using logic that negative 4, 3, totally our answer. Okay, so let's see example number 2. Again, we're just finding midpoint. So right away, we can apply the midpoint formula. The x value of the midpoint and the y value of the midpoint can be calculated by averaging the x's together. So x1 plus x2 over 2. And then separately, averaging the y values together. All right, so for the x numbers, for the x value of the midpoint, x1 plus x2 is going to be 10 minus 2 over 2. I'm getting those right here. 10 minus 2 is 8. Divide that by 2, and we get 4. So the x value of the midpoint is equal to 4. For the y's, which we can completely calculate separately, we have 8 and 5, so 8 plus 5 over 2. 8 plus 5 is 13. Divide that by 2, we're going to get 6.5. Okay. So the coordinates of the midpoint should be 4, 6.5. Okay, now in terms of checking that, let's construct that the segment really quick. So we have C at 10, 8. That goes all the way to D at negative 2, 5. And we're supposing the midpoint is at 4, 6.5. And so again, let's just do a quick counting exercise. Going from 10 to 4, it goes down 6 values. And so from the midpoint to our next one should also go down 6 values. Well, if we take 4, subtract 6, we're going to be at negative 2. That fits perfectly. Same thing with the y's. So if we go from 8 to 6.5, that's going down 1.5 values. 6.5 to 5, also down 1.5 values. And so this being our midpoint, 100% checks out. Okay, so another one where we just have the values. So we have P at negative 12, negative 9. The other end is going to be Q at 2, 10. Okay, and so we're supposing we have some midpoint kind of smack dab in the middle. Okay, relying on our formula, let's add our two x's together. So negative 12, add 2, divide by 2. Negative 12 plus 2 would be negative 10. Divide that in half. The x value of our midpoint should be negative 5. Okay, and so this midpoint here starts off with a negative 5. Calculating our y values. Okay, we have negative 9 plus 10 all over 2, which is going to be the same as 1/2, which is the same as 0.5. And so the y value of our midpoint should be 0.5. Okay, so coming back here, so it'd be that, and then 0.5. Okay, let's do a quick check. If we're going to from negative 12 to negative 5, we're actually going up 7 values. And so if you start at negative 5, go up 7, you do end up with 2, just like over there by Q. Negative 9 to 0.5, that means you're going up 9.5 values. And so 9.5 plus 0.5 is going to be 10. Okay, so it seems like it's all going to check out in terms of our midpoint. So x midpoint, y midpoint, negative 5, 0.5. Okay, so that's pretty calculation heavy. Okay. If we have a graph, we can actually maybe work this out a little bit faster. So just like with the grid, if we on the Pythagorean theorem, you have options. You have options here too. If we want to start here at the purple point and end up at the green one, we can just think about the travel amount. And so we can go over a certain amount, and then we can go down a certain amount, and that's going to be the full travel. And so if we go left, right, that's going to be 1, 2, 3, 4, 5, 6, 7. And so the change in x difference here would be 7. And then to go to the green point, we'd go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the change in y value here would be down 10. And so if I want the midpoint, I just got to do half of that. And so instead of going over 7, I can just go over 1, 2, 3.5 to here. Okay, instead of going down 10, I can just go down 5. So 1, 2, 3, 4, and look at that. It's a point, literally, if I go down 5 units. And so like the midpoint here, we can intuitively decide has to have the coordinates negative 1.5, 0, which is just the coordinates of that point. Okay, I don't think that work is different. We're still really just finding a distance and cutting it in half, just like we did with the calculation. Although, like with a graph, it could be a little bit more simple, so to speak. again, going from P to R, we want the midpoint. Well, going from P to R, we could go down 2 values and then over 2 values. And so that means the halfway point should be down 1 value to here and then over 1 value to here. And so the midpoint in this case would have 1, 2, 3, 1, 2. Okay, so you have the coordinates 3, 2. And just like before, we can also track that with our x and y values. I mean, check this out. Going from 2 to 3, that goes up 1 value to the midpoint. So the midpoint to the other endpoint should also just be another 1 value, and it is. Same thing with the y's. From 3 to 2, we lose a value. From 2 to 1, we lose a value, confirming that this should be absolutely the midpoint. Right? So midpoints of this test seem super imbalanced in terms of how much they're worth, but this is a work that we are asking you to do. So we had a lot of class practice as well. So this plus the class practice should give you plenty of opportunity to calculate the midpoint, right? And that's going to be on your table for Wednesday.